Alright, on the next problem, well, using Newton's method to approximate the given number up to 8 decimal places. We're going to let the calculator do the work. So, and it seems my scientific calculator gets stuck after 4 iterations for some reason. I'm not sure why, but I'll use my other calculator. So in this case, we're trying to figure out what this is accurate to 8 decimal places. Well, if I let this equal x, this means x to the 5th equal x to the 8th, not even to the 5th. X to the 8th equals 500, right? So I could say f is x to the 8th minus 500. Move this to one side, and I'm trying to figure out where that equals 0. Well, there's my function. To write the formula now, x sub n plus 1 is x sub n minus f of x sub n, that's x sub n to the 8th minus 500, divided by, what's the derivative of that? Isn't that 8x to the 7th? 8 times x to the n to the 7th. That's all I have to do. The catch, I need to figure out what the first choice is. And that's always a dilemma. If they give it to me, that's fine. If not, I could try and predict what that is. I could kind of guess, sort of speak, what that is. And if I throw a 2 in there, that'll be negative. And if I throw a 3 in there, that'll be positive. So I know the 0 is between 2 and 3. If I know an interval where the 0 is, I always choose the midpoint. And there it is. Now, if I get my other calculator, and this calculator, let's keep it that way. If I take 2.5, enter. And now if I take my answer minus parentheses, my answer raised to the 8th minus 500 divided by parentheses 8 times my answer raised to the 7th power. It did my evaluation. That's 2.8. Let me copy that down. And it's right there. Okay, and if I do it again, well, let's see. X sub 3 equal. And all what I have to do is go back up and evaluate it one more time. There it is. And if I go for X sub 4, I'm going to go in again, go back up, and evaluate. I want it accurate to 8 decimal places. I'm going to keep on doing this until I get it accurate to 8 decimal places. 2.1. Now it's accurate to 1 decimal place. Hey, that's very good. Let's do it again. And that depends on your first choice. There it is. Now it's accurate a bit more, 2 decimal places. Well, they want it to 8. Well, iterations. Normally they ask, how many iterations did you have to do until you got it to be that accurate? That means, how many times did you use this formula until you got what you want? Now it's accurate to what? 1, 2, 3, 4, 5, 6. 2 more. Almost there. This is not linear. That means it doesn't take the same amount of steps. Sometimes from the 2nd to the 3rd, you would notice that you cover a lot more accuracy than the previous. And let's see. There it is. It's accurate to 1, 2, 3, 4, 5, 6, 7, 8. More than 8, but that's what it is. So the solution, the 0 actually, or this is 2.1745559. The first thing they asked us to program, when I took programming, C++ back in my days, they said program the Newton's method. Alright. On number 16, find the positive root between those two. Well, that's a bit tricky. Find the positive root. If I set everything equal to 0 and say let f equal 3 the sine of x minus x, basically I'm trying to figure out where that equals 0. Same deal. Now I am going to get you the graph. The graph looks something like that. There is a negative 0, there is a 0. They want the positive. So if I glance at the graph, 1, that's 2, that's 3. It seems it's to be between 1 and 3. Well, I'm going to take 1, 2, 3. I'm going to take 2 because that's the midpoint. So I'm going to let x sub 1 be 2. X sub n is 2 minus 3 the sine. Make sure your calculator is in radian mode when you graph or when you do the derivative of this would be 3 cosine of x minus 1. And now if I input this in my calculator, and let me show you how that works, 2 enter, and if I take the answer minus parentheses 3 times the sine of my answer minus the answer divided by parentheses 3. This calculator, you don't have to put multiplication. It figures out everything. Make sure you use your calculator on the homework and figure out how that works for the test. And if I hit enter, this is the first 0 I get. Now, one thing about this calculator as well, I don't have to take 2.3 and hit second enter. If I hit equal, it'll do it again. It'll take this new solution, plug it in there, and evaluate it. And I want it accurate. They set the 6 decimal places, as you see right there. So this is accurate to the first integer. Now it's accurate to 2 decimals. I need more. And now it's accurate to 6 decimals. So this calculator, your calculator might not able to do this by inputting a 2 into it. This calculator could pretty much just by hitting the equal command or the enter figures this out. So this was your first guess. This is the first iteration, x sub 2, x sub 3, x sub 4. It took 5 iterations until I got it accurate to 6 decimals. 1, 2, 3, 4, 5, 6 decimals. Alright, and there's the homework.